We're going to be looking at parts of a circuit and circuit diagrams. This is video 21. Here we go. The essential question is, what are the critical parts of a circuit and how do I represent them in a drawing? We're going to learn how to do circuit diagrams. So when we're all done, you're going to know what this stuff is. What's this thing? What's that thing? Do you know? Well, you soon will. What's really happening in a circuit? So I'm going to give you the simplified, quick breakdown of what's going on in a circuit. The first thing you need to know is that the electrons are already everywhere in the circuit. Anything that has atoms is going to have electrons, but they're relatively stationary and staying close to their home atom. Now, when you close the circuit, one of the battery's sides has an excess of electrons, and the other side has an excess of protons. And the electrons in the circuit are going to be drawn towards the proton end of the batteries, which is positive, and they're going to be pushed away from the electron end of the battery, which is negative. This excess of positive on one side and negative on the other side creates a push, and this push is a simplified way of thinking of voltage, which is an important part of circuits. And the more voltage, sort of the more force that we use to push the electrons through the circuit, and in a sense, you end up with more energy in the circuit in that way. Now, if there's no path, the electrons won't move, but if there is a path with resistors and wires, then the electrons will rush through, pass through the resistors if they have to, and do things like heat up a stove, or turn on a light bulb, or turn an electric motor. All kinds of fun stuff. And now we get to the next part. The parts of a circuit. The four fundamental parts of a circuit are the energy source, the resistor, the wire, and the switch. We're going to talk about each one of those now. The first one we're going to talk about is the energy source. So this is where you sort of plug the circuit in. This gives electrical energy and force to push the electrons through the circuit, and they also pass through the energy source. A battery, a wall outlet, a solar panel, a generator. These are all examples of the energy source. And here are some pictures of those things. We draw a energy source using sort of the simplified circuit diagram. You can also draw it horizontally, as I have here, and sort of the larger side of the canyon in between is positive, the smaller side is the negative side. Next, a resistor. This is the part of a circuit where typically when you want something to happen, it happens here, whether you're transforming energy into motion or heat or some other kind of energy, whatever job you want the circuit to do, it happens at the resistor. Light bulbs, toasters, motors, buzzers, and you can even have a plain old resistor, which is something you add to a wire to change the conductivity of it depending on what you need to happen. They play a big part in computers and large electrical circuits. Here's a resistor. If you have more than one resistor, typically you will label them something like R1 or R2, R3, and that's how you differentiate them. You can also draw them turned 90 degrees, like so. Wire is something conductive that makes a complete circuit from the energy source to the resistor and back to the energy source. Typically, you just draw some straight lines in your circuit diagram. The important thing is that the length of wire doesn't really matter that much because it doesn't change the resistance for simple circuits or the amount of energy flowing. Electrons don't prefer long wires over short wires or vice versa. Switches and buttons. Sometimes you want electrons to avoid an area. Maybe it's a light bulb that you don't want to turn on, or a buzzer. And so you will build a switch into your circuit. And this is a place where you can sort of open and close the connection of wires to choose to turn a resistor off and on. And what that looks like in your diagram is simply an arrow that is closed or open, like this one is open because the wire portion doesn't connect from one side to the other. And it's labeled S1 because it's the first switch. Alright, last thing I want to do is take you through a circuit diagram and kind of show you how the different parts work together to create different effects. If you're designing a circuit, you're going to use combinations of resistors and switches to control the brightness or the speed of motors, and sometimes you might want to have one motor on and another motor off, and lots of variations on that. So let's show you how these things work. First of all circuits need a power source. So that is one thing that is not an option, but you will often see combinations of one or two up to any number of resistors which represent things like heating coils and stoves or light bulbs or motors. Power has to run out through out of the power source and around the circuit and back in. And hopefully you've noticed right off the bat that in its current state with S2 open, this circuit doesn't turn on, as in power does not run through R1 and R2. So how it is now, R1 and R2 are off, and I'm trying to draw that as quickly as I can click. So how do we turn these on? You need to close S2. So with S2 closed, I should figure out some sort of shorthand for this. Now you've got a complete circuit through R1 and R2, and these will turn on. O-N, O-N, boom. So there's one option, but you also notice that there's another switch, S1, that we can manipulate. So S1, when S2 is closed, is in charge of turning off and on R1. So it's like a secondary switch. If you close it, you create a pathway of lower resistance, and the electrons will avoid R1, and it will turn off again. So only by leaving S1 open will power have no choice but to go through R1. So here is your complicated diagram. You might have to watch it again from beginning to take the notes off to have it make sense, but this is essentially how these diagrams work. Good luck, and don't forget to do your summary in class with your fellow students. We'll see you next time.